today we will create simple counter smart contract on FunC. So we have created basic repository that you can take and start with. So how you can start is to write your first command line is npm create clone. I think I can just um, so when you start this command, you can choose your zone, we can see that we have tone port, and crypto. This library is used for interacting with tone inside JavaScript. So for example, you can create tone cell
Entity.
And by using JavaScript libraries for tests. Then as you can see, we have a test folder, and there are like already precompiled tests just for deployment, but nothing more. And inside scripts, we have some helpers. And the main folder that we want to see right now is contracts, and our main file is password keys. So we can see here imports, and the library is like a standard library for FunC. There are like some helpers that you might want to use inside your contract. So we can start writing our first contract here. So I think I should say that include the function, including like some files that we want to include here. So this like standard library here with standard methods, and receive internal is our like main function where everything will be happening. So there are a few ways to create your functions. There are a few versions of functions in FunC. For example, this receive internal will work only when smart contract will receive some internal message from other smart contracts, and also we need to have some get methods for getting some data from the store of the smart contract. So we can make our first get method with some basic, just return some number. So let's create our get number method.
Do you mind if I interrupt for a second? Sorry, I will sometimes interrupt, Vlad, because I will try to, if I see some point where I could give a bit more explanation, I will give it. So basically in Ton, when we program contracts, everything is kind of like whatever happens on chain, this like whatever messages are going on chain between entities, between contracts, this is internal message. You will be working with handling internal messages, most of the coding practice you're going to have. And when we try to write something off chain into the contract, then we would have to, our contract would have to be able to handle external message. So external message is basically sent from everyone or nobody, like, or from outside of the network. It's like you don't have to have a entity for in order to send the external message. And external message, when we write, so basically receive internal, we are writing a handler for internal message. So all the coding is how you handle the messages that go between contracts. And we have certain, like this is standard parameters that get into, that you receive when you handle the internal message. Maybe we're going to talk about them a little bit more, but just this difference that external message, like it doesn't bring any money with it. So internal message actually is bringing money. So message value, this is like amount of tons that are coming with it, you know? And external message, like the blockchain gives you, I think something around 10,000 grams, like small parts of ton. It's a free money when contract can decide if the contract wants to pay for this message or not, because everything has to be paid, right? So basically, most of your coding practice will be around doing handling receive internal messages. So basically, all your logic is like you write a logic that when you get the receive internal, what the contract should do. And Vlad is going to go deeper into that, but maybe another thing worth mentioning is the getter methods. In Ton, contracts cannot call getter methods from another contract. So once we do getter method, it's basically we are providing the interface for the outside world, you know? So we are providing an interface to this contract, so that's basically the main way to read from the memory of the contract. So you will have some data inside of the memory and you have to read it out like off-chain with API or whatever. And this is why we have this getter method. Yeah, I think maybe let's talk about what kind of parameters we get into the receive internal
Yeah,
function.
sure. So as you can see in receive internal, we have a bunch of parameters in that can be set, but we might not use them if we don't want to. And as you can see, we have my balance parameter is in. It's just number of nanotones that your smart contract right now have in the balance. Also, we can see message value is message value of incoming transaction. Um, in nanotones again, so it's just a number. So here we can see the cell. Cell it's like this specific type of data structure inside FunC code. And in message flow, this is like full message, full cell of entire message that came to our smart contract, and we can work with it, or we can work with in message body. So in message body, it's just body of the incoming transaction, and as you can see here, we have slice type. So slice is cell that was packet. So cell is the packet structure, like zip archive, for example. And slice is same style but unpacked, and you can interact with slice inside smart contract. But you cannot interact with cell. You need to parse it into slice if you want to take some data from it.
Does anybody understand what is cell?
It is something like Google protocol, so it is some binary format which you cannot interact with, like if you haven't parsed it.
So cell is 1023 bits of data, and plus 4 ref to other cells. So 4 ref is the reference, so you can plug this amount of bits inside your cell, and also you can create 4 reference to other cells. So with with such infrastructure, you will be able to create 3 of the cells, and you can plug like almost everything. But you need to have deserialized functions and serialized functions. Okay. Yeah. Questions?
How works slice type?
What?
How does the slice type work?
Slice type. So slice is like completely the same stuff as cell, but unpacked. So slice is like the same data that we have here, but it will be cell that we can parse.
I think I have maybe we should definitely stop a little bit on this. I have day 2 from DoraHacks. Let me share my screen. Just maybe it will be very useful for understanding before we actually get into the deeper code.
Yeah.
I cannot share the screen because let me send you a link. Okay.
Sure. So I should say that cell is packet structure that you can just answer, and slice the transfer between contracts, and contract will receive some cells, and slice is just the same data but packet, and you can interact with slice and get some data from it. And so most of the times you will interact with slices.
I sent you a link on Telegram.
Yeah. I have a question.
Yeah.
Do I understand it right that in this function parameters in MSG full and in MSG bucket are completely same data, but in different formats?
So in message flow, have more data, but it's including in message body. In message body, it's just body of the transaction. So from in message flow, you can take sender address, you can take like amount, other data. But in message body, you'll be able to take only the data that was sent to you. So for example, someone created transaction with body like hello world, or something like that. And in message body, you will see only hello world. But in message flow, you will see like sender, like amount that was sent, other stuff. And also you need to like kind of open the cell with begin text.
Why? Why don't we use slice everywhere? Why do we use cell? Because sometimes we don't want to waste performance on packing when we do need this data, or there is some another reason?
So basically, all the data is stored as cells. Cells are connected to each other in a way, and slice is it's basically an address from which part of the cell you should read this data. So when we say slice, it's not like a separate data type. It's like data type which help us to work with cells, because we don't want to parse like how it happens in Tron that you're actually reading from a cell. I think I'm hearing myself twice. So basically, you get a cell and you begin parse, and you start reading like bits, and it's up to you. So sometimes there's like predefined structures, like these 40 bits are for flag, like these 4 bits are for flags, certain flags that would tell us something about the message, and then there's next amount of bits, and they are for something else. So for example, basically slice is just like that. Slice is like certain part of this bigger cell. So slice is giving us the address from which bit we'll start reading, basically. Like, but this happens under the hood. So so we have slice for our own comfort to actually address immediately from certain part of the cell, But even though like we just have the first address, and then we will read bits again, and you will see that when Vlad is going to actually start reading bits and expecting them to be a certain structure, And some bits are predefined, so you would have to have them. Some bits are like a standard, we kind of agree that then we will have these bits like operational code or the query ID. We're going to talk about this later, and then there's like complete carte blanche. You can structure the message the way you want. You can send like 5 integer, then reference to another cell. So basically, you can be creative about what kind of message you compose in there, So basically, slice and cell. Oh yeah, can we go through these slides a little bit? So maybe you can even go to the beginning. I just don't remember what if we have something good there. Narek Abovian is the person who created this npm create ton, and his team. And if you want to watch this was a talk, like basically as a broadcast. If you want to watch it, you can go to the Ton company, Ton and Co. Like I gave some visit cards to you, and there's a like onboarding course. And there's a few videos that are actually like when we talk about data types and everything. So this might be a big help for you. But let's maybe just go through slides. I might repeat. So, quick question: do we have anybody from EVM, Ethereum Virtual Machine? One person. But maybe it will be good to learn about Ton when we actually compare it to EVM, and you will learn about both. So contracts interact by sending messages to each other. This is clear. We already talked about this before now. Then calls between smart contracts are asynchronous and not atomic. So when we call another contract in a way, we cannot wait for the answer. So it has to be like the answer that will come, it will come asynchronously. We don't know when it will come. So we treat it like we send something and we might never hear back, So this is what means asynchronous. Your smart contract cannot run getter methods on another contract. I already told that before. Contract has to pay rent for its on-chain storage. This is also important part, because you would have to, when money come with the internal messages, you would have to do balance management, because at some point your contract can, if you don't take enough commission for actually paying the rent, your contract will end up on the archive nodes. So it will not be active anymore. So and everything is stored in cells. So this is just a recap of what we talked for the last 15 minutes. And we can go to maybe the next slide. So what is cell? And this is what Vlad already said, that everything in Ton is stored in cells. A cell is an immutable data structure. So it is immutable. You cannot edit cell. You always get a cell that you are actually reading, and you cannot write back. You will have to create a new cell and replace the old cell with a new cell. This is some conceptual things you would need to understand, because at some point you will get on the code and you'll just maybe not understand what is going on. And then, of course, this data that you can store up to 1023 bits of data, not bytes, it's bits. And BOC, bag of cells, it's a binary serialized representation of cells. So basically, when we are going to deploy a contract, we will have a BOC, like string of BOC. And basically, this is a serialized set of cells. So once we deploy a contract, we actually pack in cells into a serialized way, and it's like basically part of the memory. So when it gets into the TVM on the node, it gets into the memory, and then it's like, this is why cells is very important to understand. This is why I'm focusing so much on that. Sorry for interrupting your coding part, but I think it's just important that we actually make sure that the guys have conceptual understanding of things they need to start programming. And anybody has any questions on this? Doesn't make sense for you why we have cells and stuff? Yeah?
What when we want to receive more than 1023 bits of data?
So I think I can handle this. So bag of cells is 3 of those cells. So each cell can handle 1023 bits of data, but those cells can be a bunch, more and more, like in the tree structure. So you will receive just one cell, and you will have 4 references on other cells, and other cells will have up to 4 references on other cells. And that's why you will have like big amount of cells that referring to each other, and like the main one doesn't have references. So it's like you will start from this cell, and then you will go to the tree.
Yeah, but we are going always, we're starting from one cell, and from this point we need to find other cells.
Yeah.
Or are we able to receive from the user or from other contract more than one cell?
No. Every time you will begin with one cell.
Oh, that always one cell.
Yeah.
And it's always a tree. So when we will talk about storage, so you have a certain place in your contract where that is treated as your memory. So, and you will see that it's one cell. You are given one cell at the beginning, and then you build your tree, and only you, as an engineer, only you know what is going to be the structure of this tree, what kind of data is going to be stored there. And yeah, that's a good question actually, but it's important to know that you always start with one cell. Even like in message body that we saw in message full or something. It has, there's one cell, and you get so basically cell, it gives you an address of a cell that you begin parse it from the memory. And once you parse it and you know what is the structure, you end up processing maybe 15 cells, but you start always with one, because this is your pointer. It points you at where you should start with it. Does it make sense?
Okay, nice.
Yeah, a few more data types. You want to run through them?
So you can handle it.
So we have int, 257-bit signed integers. So we basically we can place in one cell, we have how much? 6 ints? 6 integers. So, I mean, like this is the size of the bit of this data type in bits. So you would have to, there's a question?
Yeah. Say that it's good like a tree with the one cell, then like 2 cells, 3 cells.
Yeah.
But can we connect
Leaves?
on same level to each other?
No.
One top cells and 2 under that, and they are connected.
Actually,
You have a triangle.
actually, you don't need to do this in smart contracts if you will develop it in like certain right paradigm of developing in FunC. That way, you will not be able. You don't need to have like such structures that will have some multiple entry points to this data type. So it's like I don't know. It's getting clear. You will get used to it.
Yeah, but to answer your question, that basically it's not like if I understood the question right, can one cell of one branch interact with another cell from another branch? it's not like the question, like it's actually a good question because me explaining why it's not a question, you will not face this problem ever, because basically you are given, it's like you are given a material and you have to process it. So once this nestiness, so that we have one cell and then there can be 4 references to 4 another cells. And I believe your question is like, so we got references to two different cells. Can there be a reference to this cell, like from this branch? No, it doesn't make sense. It's always one-way road, because it's basically you have a big amount of data, not big, sometimes not big, and it is spread down. It's spread down because this is how you are actually like forming the final result. So you would always keep reading. You would have to, like, at every point you got 2 references, you would have to read out one and then you read out another one. It will not reference you to the same. It might be, this cell can have same data as here, but you can always get a certain reference, like here you got reference to this cell, but this one will not reference to this one. It's just not how it works. It's always one-way road. Maybe I'm not explaining it in the best way, but it's just you would just need to treat it as a like one-way road without intersections, but branches, and it branches like a tree. So yeah, I think it kind of didn't expect that we will have such a good discussion. That we will also share the recording of this on YouTube, if you don't mind, so other guys can actually participate in this. So ask questions, because this might be useful for others as well. Yeah.
So here I have a question in regards to these slices in the cells. Are we able to pass any flags or parameters into that cell without parsing it into the body? I don't know if I parsing it correctly. In a scenario where we are, for example, scenario that we are getting some message from the user, and before we will start the processing the body, we would like to make some if statements to, for example, properly decide about other functions which will process this data. Are we able to pass something outside of the body, just like flags, some integer values, something?
You want to handle it, or should I?
Yeah, you can take it.
So basically, that's a good question, because I see that you're already building the plan how you're going to handle the logic. So there are flags, but I'm just curious, what do you mean by body? Because the cell itself is a body.
Yeah,
So
I was thinking more, for example, inside a body we have like this code word, yeah, or something. And I would like to, before I will read the message, I would like to decide where this message will be forwarded.
okay.
So if I'm able to do that without reading the message body and read the hello word, I would like to pass to myself some kind of flag. Like this flag inside the like something-ish switch statement, and the block process decides where the logic will go.
I think I can handle this now. So,
Sure.
as I understand, you are referring to this part of the smart contract where you have message flow and message logic. So, under the hood, message flow is just itself, but everyone in FunC development field agree that in message flow we will have some certain structure. So, if receive internal, you receive some. Can we call it?
Yeah.
Is this structure closed, that meaning all of the parameters available in the message fold are locked to the messages or information which can be only controlled by the tone, or can we?
In message flow, I will send the link maybe later or show it a bit later. We will have like documentation that tells what bits what you means. So we will have like few bits that will mean some flags, like other bits will mean some like other flags, some coins that will be stored, and at certain point you will have like referent refs. So first ref you will referent to the message body, or if you want to, if you will, so you have an option to store message body inside the main cell, but you will need to handle like how big this message will be. If this message will be like small enough, then you can store it inside the message. But if this message will be bigger than like some certain amount, you will need to store it inside a reference cell, and that's why you will have like one cell, like full cell with a transactional cell, and this like one main cell will refer to your body cell. But in your body cell, you can write some flags that you want to write, like your custom flags, and inside this like body cell, you can create other reference that will depends on flags that you're creating there.
Okay.
I mean that in this structure, you can create everything that you want to, but in this structure, there are like some already determined parameter that you should create here, determined like
Okay.
type of the cell. So there are like other types, builder and tuple. So tuple is the same as array in JavaScript, but we have interesting thing here is will contain up to 255 components. So you need to understand what you store in the tuple, and you should not have like thousands of data that you're trying to put in the tuple. But also you have other interesting thing in Tom is lists. We don't have this data type here, but it's same as tuple, but you don't have limits on the amount of components in this array. So in list you don't have limits, in tuple you have limits. Also like the user data type, and user is cell that was finished yet. So you can start to create your own cell from like I can show here. So user type is begin cell, and you can store something here. So for example, store view int. So we stored 1 byte where we have the 1, and we didn't finish at the cell. So that's why our data type here is user. So we have so in this cell we have data type user, and we cannot send this cell to the smart contract, to the other smart contracts, or we cannot store this cell. We need to finish it. So to finish the builder, we need to have we need to use build, and then we need to write end cell. With that function, we will kind of close the cell, and finished cell is like closed cell with 1 byte in it that stores 1. If we will not write here end cell, then we will have a builder. If we will have, if we want to make a slice, so so we will have finished cell begin parse.
And this slice will be actually the address of the first bit, let's say, of the cell. So now once we start like for example, if you will go with like slice cell dot read uint, and I don't remember, load uint, then you would just start loading from this particular address.
So, and as you can see here, this done is some sort of cancel log, some sort of print inside some contract tests. So you can write your own test, and you can dump some data in the console. And here we can see our slice that we just created from our cell that we created from our builder. And then we can have load uint function here that will load 1 byte of our cell that we just write here, so it will be 1. For example, we can store here 8 bytes, and we can write number 3 here, and then when we will read the data from the int, we need to write 8 bits here. So that's why we will read first 8 bits of that cell, and we will have 3 in the output here. So that's how you will interact with builders, cells, and slices. Yeah.
How? Because this example, we build the cell, and then by right when the cell is finished, it's already stored on the it's already stored. Yeah, it's already set. So can we revert it depending how it looks, where we want to revert the cell, delete it, remove it? Imagine that scenario where the developer is processing some logic, he's creating a cell, he saved the cell, he made a mistake, and then after creating the cell, he's checking some business logic, and business logic decides that the cell is incorrectly and we need to remove it.
So the first thing that you need to understand about FunC, you should not do mistakes in some.
But maybe the flow that you explain, it feels like you treat cells that we are working with them like, and then we put them manually somewhere. No, it all happens in runtime. So you're writing a script that in runtime is working with the cells. So basically your script, you can just understand that you don't get the desired result, and you have to rewrite the logic, how it handles the cell, you know.
So I can show you how you can handle this situation here. So you have some data that you want to store in the cell, and you know that in your smart contract you will have some business logic that will happen, and if this business logic this condition will be true, then you want to revert some statement in the cell. So that's why you cannot store it before the condition inside the cell. You will store it like here. So you can have your build cell, and then you can store some data that you're working on. Actually, you know what? We can make it like that, and data will be changed here. So data will be 1, data will be 0, everything. And if data will change, you will store after the statement, if statement. But if you even don't want to store it at all, then we can just write it here and do not have else. So that's why you will have some data stored inside your cell if some condition will happen, and if this condition doesn't happen, you will not like store the stuff here. But anyways, in like your next logic, in like other smart contracts. So for example, we will send this sliced cell, this finished cell in other smart contract, and other smart contract will expect something. And smart contract code will read it byte to byte with some certain structure. And your new smart contract will expect that, for example, you have first 8 bits that means some flux, for example, and second 8 bits that will depends on your some condition, some business logic. And if you will not have 8 bits, like at the second point, like receiver smart contract will fail because he will not have like new 8 bits to read. So
it will be underflow.
Yeah.
The exit code, there's a TVM exit codes. It will exit code with code 9, which is underflow, and you can see all the codes in the documentation.
So that's why you, if you don't want to store something in the smart contract, you can just store zeros and still have this structure, like the same structure.
Can I ask a question from the guys? How does it feel so far? Do you feel like it makes sense for you? What we're going to do while we're going to code the contract? So basically, what we're going to do, we're going to manipulate cells and write logic around cells. So that's why it's so important that everyone in this room understands how cells are, what kind of thing it is, you know? Yeah.
I have one question in regards to security. And comparing to EVM, how we can depend, or if this is in the scenario that we need to depend over re-entrancy attacks. For example, the contract can say the logic, for example, most of this is some race condition-ish like issues, called re-entrancy attacks. Are there some best practices that we should follow to avoid that, or by default are there to make sure it will not be the case?
I'm not sure I got the question, honestly.
Yeah, same.
Can you maybe rephrase it? Maybe.
What if two people will try to, or one person, bad actor, will invoke the contract 2 times, where the second invocation will be based, the target, how to call it? Like, the intrinsic attack is based that I will be able, with second request, with second transaction, to read and launch the business, the logic of the contract before the first one will be finished. So the first one is finishing and writing the data, for example, changing the balance. So I will flood the contract with 10,000 requests, and first request will change the flag, but the other 9,999 requests will invoke the contract before the first started changing these flags or the sales values. So then all these 999 requests will not know about data changement, which they should follow. I don't know if I explained that correctly.
I think I understand your question. It's like how, so if every request that comes into the internal as an internal message, if the business logic is dependent on certain like value that we have in storage, how do we make sure that the second guy who comes will not be kind of like, will have the value that would be resulting value from the previous one? I honestly speaking, I don't know how to answer that. Maybe Nikita has an idea.
In general, validators who process the transaction, and when you send the amount of transaction, the digit would make a change on that and include it one by one. By this reason, so we couldn't guarantee if you sent, for example, 1,000 transactions in one time, we couldn't guarantee the correct sequence of kind of unknown things which would be decided by the judge. So
if someone will speak, just use my this one. But that doesn't answer your question. Yeah, actually, now I understood better that there's a sequence of transactions, and they will always be executed one by one on validator node.
So then the smart contract would have some results for each transaction. Maybe a few first results, then some transaction changing like the rest of them. Make it very real or something.
This scenario, maybe we'll leave it like we need to check it later, because as well as our blockchain have some validator nodes, of course, to check the continuity of the ledger. But most of the blockchain are facing the same issues. So as a developer, how I can protect my contract over the snare of re-entrancy attacks, for example, how I can deal with that with some best practices.
So from my point of view, I like if in my logic I have some like transactions that should execute one by one, I just write a waiter of transaction finalizability for the first transaction, and then first transaction will be finished. Then I can execute like second one. And if we are talking about like our own front-end application where or like backend application where we will have like a bunch of transactions, we can just write a logic that will wait when other transaction will finish it, and only then we will execute new one. But if we are talking about some sort of hacking of the smart contract. I'm not sure that I understood it right, how you can have the smart contract in such a way. I can see that you maybe can change some smart contract data. So maybe you want to tell that we can send transaction before, so we can see that user transaction has executed, but we will send like another transaction that we will be like the executed before, and maybe we can change some data in the smart contract. User transaction will be executed only after that. I'm not sure that I understand the question right. We can talk about it later after the session, and yeah, that's definitely a good question.
Usually, the smart contract will logic to the data. Usually, for example, for NFTs or for crypto accounts, smart contract saving your address and it will process only the transaction from your address. There is reason no one would run some migration on your smart contract. In this way, the smart contract protects it.
So I guess we can continue working on our smart contract. So that was just some examples.
May I have final call? Does everybody understand what's going on here? Raise your hand if you got what is cell and you understand how to work with it. Should we go another round of explanations or? No? Okay, I will accept it as an answer that everyone understands. If you're shy, this is up to you because you will find yourself at the moment that you don't understand what's going on. So we are here to make sure if you're shy, just come to me and ask some questions after we finish. I actually suggest maybe to have a small break. Yeah. We're like 45 minutes now into this lecture. So let's make a small break, and after we will proceed with actual writing code. So thanks, Vlad, for giving us this time to go through the cells, because I think this is very conceptual things that you need to understand. And I'm happy that we're able to talk about this.
Yeah, I spent a bunch of hours to understand how cells works, but right now I'm explaining it like in 45 minutes.
Yeah, but I think we did a good job because I loved what kind of talks here were. So let's make 10 minutes break, maybe even like, what time is it? Yeah, it's like 10 minutes to 3. Like we have 10 minutes break. Like in 10 minutes we all meet here.
Okay.
Я так понял, билдер создает на основе цела еще один цел, да?
Нет, билдер создается просто, да, он просто с нуля из ничего создает цел. И ты важно его зафиналить, end цел.
То есть он создает два.
Блюпринт это под капотом, ну, это я нашел под капотом. Да, просто MQ-электроны это больше люди. Ты можешь либо, может, я поговорю с пацанами, чтобы сделать телеграм-группу для суппорта, именно MQ-электронов. Я туда всех слал, что там, потому что я лично общаюсь с разработчиками, которые делают MQ-электроны, все. И даже они меня в телефон нанять. Так очень охуенно.
Когда ты проверяешь типовую транзакцию, она хэш транзакции добавляет в себя, цензурирует новый хэш. Так, по цепочке. Таким образом, все транзакции связаны с помощью этих хэшей. Ну, параллельно еще, я знаю, я еще поэтому, то есть, ну, и, значит, рассказываю, как это работает. Да, поэтому работает. То есть ты, что значит ты отправил, ты взял транзакцию, сдал потом, что Владимир отправляет Вите $1. Ты берешь свой приватный ключ и причем свою транзакцию и типа у ты это отправишь тем, кто транзакции зарабатывает, да, и получается через время да, действительно посмотреть ключей, типа, pointer to the cell itself.
So when you call the variable here, under the hood inside TVL, top virtual machine, when you will interacting with this variable under the hood, this variable will be interacting with the cell that was referent to. So this wise will referent to some cell, and this cell, you don't need to write it here, so you can just work with it.
Basically, slice is a set of 3 pointers: a pointer to the cell, a pointer to the begin of the variable, and to the end of the variable, right?
Yeah, kind of. Well, also, if you want to, we can just console log that variable, and we can see what's inside. So actually, I don't know if you have some pre-compiled in the library compiled tests, or I just want to start with the program. So let me check if we will have inside packages on. So we have test, and inside test we will have just deployment function for now. So also maybe it will be really helpful to show that how we make a test, but I will give this opportunity to Mark later. And right now I just want to show how console log inside the smart contracts works and what will be inside itself. So what we will see.
You use brackets.
No, that's not the point that I'm thinking about. I'm thinking about this logic that we have here. This is not like the simple test of the internal message. So I'm not sure that I want to waste time here on the internal messages in this test.
Yeah, let's not focus on this. Like, back to the question that you said, like it's a set of pointers. No, it's not a set of pointers. It's a single pointer into the certain cell, into the certain part of it, and you would start reading from it.
Yes, but like, if you have just a single pointer, how can it know how much data should it read?
You will write.
You're writing it. You're defining. This is defining where you're going to start when you're going to read, but you are defining what to read from there. And if you're trying to read something that is not written there, it's going to fail. So basically, you have to make sure that it is first written there. Somewhere you actually write it, and then you read it. And you are defining the structure of the.
But for example, in our case, we have in MSG body, which wasn't created by us, and which came from some external layer, and we don't know how much bytes does it have.
Okay, so there is going to be standard bytes. Oh no, like flags are going to be in a message full. So this is standard. We are sure about these flags and stuff. And whatever is in message body, there is basically you're writing a handler not for any message. You're writing handler for certain messages that you know are going to come. Everything else, if it fails, it's fine. Then it doesn't affect your contract state. You just return, so it fails. So if someone is going to write data that you don't know, it's just going to fail, and you don't care about that. You only care about the messages that come with the structure that you defined. And that's why we're not going to talk about like schemas. Like we actually prepare a schema for the interface, like what kind of data should be passed in there, you know? And basically, we didn't get to the operations yet, right?
Yeah,
Operation codes.
I'm just searching stuff about the stuff that we have here.
Oh,
And,
what exactly?
And about slices as well. I thought that maybe in documentation they will have some samples of like this output that I tried to show, but they don't have that. So also the really good documentations you can find on tom.org/docs, and there are like a bunch of stuff about like each functions that you have in FunC, and also you have Tom. So this is like a place where you can see how best practices on developing some like aspects of the FunC contract, but so yeah, FunC cookbook, and you can find some info here. Yeah. So in a next part of this one contract, we should take our image body and get OP code from it. So we will create variable in OP. So this variable is integer with name OP, so it's our OP code, and we will take in message body, and we will read some int from it. So for example, our OP code will be 32 bits long, and this is determined stuff that we will read every time when contract will receive a message. So
this is standard. This is not.
It's like best practices.
Yeah, it's a best practice among developers. It's not coming out of the box from the blockchain itself.
So same stuff with query ID.
Nikita, can you explain a bit more about the query ID? Why do we have this best practice?
It's just to check transactions. The query ID is passed. For example, your smart contract would receive a transaction and set another one to the second smart contract. By this reason, we will check this is one transaction which coming from one, then send it to another, and later also send it to the thing. All of them are included in the ID, and we will read the transaction and check this records.
So query ID needed to link a bunch of transactions to one like specific
path.
Link, path of your funds.
It's just an agreement, so it's not required.
Yeah.
Also, I think it uses to bounce for bounce transactions. So with query ID, you can bounce your transaction directly to the sender where you get your transaction from. So also, I need to mention that there are a few ways to receive some data from the slice, and first way is by using this symbol. That way, message body will be sliced by this 64 bits. So, for example, here we read 32 bits, and this variable you start reading next 64 from 33rd bit. It will be read 64, and that's why, for example, here we will have like 1212 or something, and at this point we will not have first 32 bits, and this in message body variable will contain only like rest of the bits without this first 32. But if you will read the data with that here, then you won't slice and change your main variable. You will just get some data from it, and the data will be the same in the main variable. It needed for just user experience of the router, so it will be easier for you to read variable by variable by slicing some bits from the slice data, and your next lines will be getting the data already from the 33rd bit, like without some extension logic of slicing some bits, of starting like from 32.
Does it make sense?
I hope that my English is kind of good and
No, I
you
understand.
how it works.
Yeah, understood. Just wanted to make sure that, because it's an important concept, you build your logic, and like, so for example, you read the body and then you assign the rest of the body as a kind of like unknown, something that you want to pass further.
So same stuff is so you can just slice some data and like remove first 32 bits by doing this without creating variable. You can just write like this, and you will just like slice first 32 bits, and your next line will start from 33rd bit, and you will work with the next 64 bits. And but we will have variable here. So next what we will do is just taking our data. So we will write counter, and for example, in the body we will put some number that we will add to our data. For example, my laptop is dead.
Really?
Yep, it's round of battery. Just give me a
Do you have a charger?
Yeah, I have a battery.
Oh, I'm blue. If I was green, I would die. Man, you're living?
I don't know if you can get this card from the top. You can join and very much more games if your name is because you cross.
It is a bit too advanced for me, but I understood the 24/7.
I will use this pause now. Spread this command. This one. I feel. This is and this is here's a link to FunC. This is our platform where you can find, first is for networking. You can find a lot of people in FunC there. Yes. And you go on. So basically, the biggest value you can get from it is that you can come there, attend Q&A. So we do similar sessions but online, and you can always like ask your questions, whatever. You can suggest who you want to hear, and we're going to invite him, and you can watch all these events there. And another thing is that if you have a project, you can just publish it there, and you can write who you need, like developer or web developer or FunC developer or designer or community manager, and we facilitate networking. So we're going to have like meetings where you could actually announce who you need, what's your project, and who you would like to have on team. And of course, it's also possible to find an investor there. So join the platform, stay tuned, and you're going to get into tone a bit faster, I hope. At least we do everything for that.
So we can continue.
You need to share. You need to start sharing.
Stream.
Yeah, just follow the link.
But anyway, I need admin term.
I will confirm it.
So I guess we can continue here. As you can see, I just created this like one bit variable. It's just 1 or 0. It's needed to understand what action we will use here. So if we will have action 1, then our variable will be summed with stuff that we already have. So if it will be 0, then it will be minus with our stored value. So here, for example, load. So that's why we will have some function with that will take our store and giving back the value of the store. Also, we need to make it import. Import is like type of the function that allows code inside the function to change the store. So if you have some function with import in the flag, that way you will interact with the store. You can interact with the store. If you have function without import, that way I am not be able to interact with the store. So I can create several the names that cause this, and I can get store by calling get store or stock data. What the name of the function?
I guess you could check in library.
Get data. Okay. Get data. So this function is native function of the FunC, and you can by calling this function you will receive the data of your smart store. So then we will just make this that begin parse, and when we will parse this, we can just return it back to the logic. And here I will write a slice. So first brackets means that we will return this type of the variable.
Can I mention something here?
Sure.
So just like I said, we were talking about how much memory you have. So you have one cell at the beginning. So basically, we got this one cell, like get data, it's a cell. It returns us one cell. And then it's up to us, depending on how we save to storage, we can actually load from storage. That's one thing. And second thing I wanted to mention, I think we didn't go through the modifiers, right? Impure, method
I
ID.
just told that if you have impure in the function, that way we can interact with store. And,
Yeah, so impure means that this function affects the state of the contract. Because if there is no impure, if there is no impure modifier, I think it's called modifiers, right?
Yeah.
Okay. So if there is no impure modifier, you just do function, and the results of this function is not used anywhere, the compiler will just remove it. It will optimize and just remove this code because it's useless. It doesn't affect the state. The results are not used anywhere. Remove it. So this is why we have impure. Receive internal is impure function. It affects the state.
Yeah. Also, I just understood that we don't need to have impure to load the data from the state.
Yeah.
But we need to have impure to write something.
Yeah.
So in storage save, we will have some logic that will write something in the store again. And in load, we will have some logic that just took something from the store and just pushed it back. And in storage safe, we will receive some, for example, int is our main variable. So our main number or something. And here we will just or something. And how we can cells inside FunC. So as you can see, we'll use the same stuff that I was show here. Begin cell, store int, and some number that we push here, and then how many bits this number will be taking inside the cell. Also, we can close the cell right here and then store it inside the smart contract storage. Store data. Maybe like this. I'm not sure that name of the function is set data. Okay. Set data. So that's why we will store our main number inside the smart contract store, and here we just getting the cell and push it back. Also, maybe we should push back integer, and here you can just unpack the cell. So how we can make this? We will make this begin pairs. That's why we will have a slice with some data that was inside the cell, and then we can make return data get unit, class unit,
Load.
load unit, and then how many bits this unit takes. So it's like 64, how we create it like that here.
So I just get back to this again. We are owners of the memory. So we actually say how the memory is going to be structured. So we are reading from it, we're writing into it. And important to know that you cannot just read certain parts. So you get a cell, as you can see, like load data, you get a whole cell, and you cannot skip some parts. You have to read everything. And if you want to change something to write certain part of the cell, you have to read everything and then write everything the same, but change, like for what you want to change. So this is important part to understand.
So right now we have our storage, and we can interact with the storage. In our place where we write actual logic, we can call the functions and load some storage data. So for example, we will take our load function, call it, and we will make some old number variable. Here in actions, if it's like some action, you'll just make int. Also, I should say that we can make old number plus equals new value that we're trying to work with. So it's like added value, and our added value is have like for example 64 bits inside message body. So this added value is will came from the outside, from the other smart contract, from the calls, and we will make all number plus added value. So that's why you have like our new number that we will store inside the store. Also, added value, and then we will just store storing data inside our smart contract.
Ah, okay. So we do calculator,
Yeah,
like not counter.
It's just, I think, more usable stuff.
Yeah. So we.
It's not-
What if we do action 1 and then action 2? So we would have to explicitly say because.
I just thought that one bit for action is kind of
Okay. Okay.
and like 0 or 1 minus or plus.
But you can have any. It's like you basically put the first part, and this is operation code. I just thought it's a.
So, and then we just push new variable inside our storage. So if it's action 0, then it will be less than old number, and if it will be 1, then yeah.
I actually thought we would pass it in op, in operation, not action.
Yeah, sure. Also, we can use our OP codes. So it's like best practice to use OP codes inside the functions. And if so, for example, let's make OP code with what? With 1, OP code 1. Then
Yeah, I would use op rather than action.
uh,
Why would you need action if you have the op?
okay. So action is like, so in our calculator we can make a bunch of actions, but if it will be just plus or minus, then we can use OP code, and our OP code will tell what our calculator will do.
Mhm.
And if you change it like that, then maybe it will be simpler. So then our storage save some data, and then return or throw some.
Why do you save old number? Okay, because yeah, you just change it.
Or we can make some throw with some number. And which number?
F.
Okay.
Никита, ты помнишь сколько? Я просто не помню. Необычно.
I guess 4 has
Oh, sorry, I switched to Russian.
our exception. And in this way, you sort of always will be sorry, maybe should just return if you end of the
Yeah, I think you should just return. It's fine.
Okay. So in our last thing that we should make is our get method, and get number will make. So for example, let's make test method just for like getting some number. Get test number. It will return just 1, and in our get number method, we will make load data and just return our number. So that's why we will have our get method for our number inside that it was stored inside smart store. So I think that's it. That's our simple smart contract that have few OP codes and that working with our variables that are stored in storage. And yeah, that's it. Next thing that we should make is tests, and while we make tests, we will test how it works. And I think maybe we will have some issues with some maybe some little issues with some typos or something. But it will be find you will find it in while you will make tests. So
My stream again dropped. Let's first try to understand if this makes sense. So are you ready to write your first contract? Like,
so that's the entire product on the screen.
yeah, raise your hand if you understand how to create a contract now.
If you have any questions, just say like line number and we will go through it.
Yeah.
Okay, I hope it's understandable.
Yeah. So basically, do we want to continue immediately or want to break? What do you guys think? Let's continue. Okay.
So I will push the code to the our system. prepare a key repo, and then Mark will just load it and then we'll continue.
Mhm.
Next laptop. I forgot the name of the Don't workshop, okay.
I will switch. I will go switch the screens on the.
That's interesting. My SSH keys. Okay, you don't see. But anyway, I don't remember my password from the GitHub. I don't know why, but okay, let's make it like that.
Because you said original HTTP is going to be changed to this.
Oh. Okay. I hope my internet will not drop. Will you send me the link?
Actually, GitHub issues.
Bruh.
Okay.
So. I think I will just switch the screen to me, and I will start to show guys the sandbox and everything, how it works.
So, yeah.
You want the Christmas tree? Yeah, it was like this. No one saw it.
Sure.
If you saw something, forget it. Okay. Like, it would be nice if you could kind of like watch out that it's streaming properly on the same link, because I would only see my screen. So, wow, I'm happy I can actually talk a bit more now. I'm a talkative person. Try to explain some things that I know. Happy about it. So basically, I'm going to go with one community repo first. And this is this repository that you definitely should take a look on, because a lot of community projects and libraries and stuff, if you want, you can scan the QR code or just, if you need to save it for yourself. So basically, there's one repository that we want to talk about. It's called Sandbox. Sandbox. And this is like local tone emulator. So basically what Sandbox is allowing us to do, so we actually import type blockchain and we create an instance. It's, of course, it's local. It just simulates it. And then we would be able to to actually send some comments. So like provider is like contract provider. We actually send an internal message with like the sender would be a like the ad like this is we are just playing the simulator. We can set any address as a sender, and we just create an instance of the contract, and we send it certain comments, and we validate the results, and um, basically expect certain behavior. So this is the major way when you're going to write contracts on FunC. The main way for you to test would be sandbox. If you okay with TypeScript, is there a question? So I thought there was a hand. Sorry. Okay, so basically, just like I said, we cannot refresh the page and expect some change. We would rather write a test. And let's see. Did you already create a
Yeah,
repo?
yeah, I pushed it. And also send the link to the draft.
Mhm. So this is a template. So we already have a certain, and it is generated template. So you can generate it for yourself for your project. Very, very handful. So what I'm gonna do, I'm going to clone it. Okay. I will make it a bit bigger so you could see. No, this is too much, right? We have to install all the dependencies. So basically, what kind of tests we're going to write? We are going to first we are going to just test if the contract was we have a proper instance of a contract, it's compiling properly, and you remember we had this like get test number. I will just run this getter method, and I will expect it to be is that the default one for let's just run. Let's see the package JSON, what it is doing the test. So it's doing just okay. Yarn test. So it actually okay, it failed. Oh, and the compile failed, right? Okay,
So maybe I should refactor my code. So
it's okay. Maybe do you want to do it or
okay, I will search.
is empty?
Yeah, because I do not remember like all those functions.
Pascal case. Okay, I where is it? Hmm.
Change it to slice empty question mark.
Like this? Maybe, yeah, okay. And why is it? No, it's right. I'm just not sure.
After you don't also there should be first right
Okay.
and in the end of the
Yeah, okay, I got it. Yeah, I don't have this highlighter from Vim. That's interesting.
Mm-hmm.
Even though I have the same language here as investors.
It's empty. Okay. Let me try. So basically, it's compiling the contract before every run of tests. So your standard workflow would look like should deploy. Okay, FunC cannot implicitly assign expression of type variable. Cannot unify type slice with int. Okay. Wait. Yeah. Okay. Important to note here. Let's see what is the code. So
You should replace inside the smart contract. You should replace where is slice empty. This weird черточку на точку.
uh, okay.
You can mix it.
Now we have compiled properly. So we properly compiled it, and now we are going to let's see what it does. Send deploy, treasury deploy, open contract, create from config. So basically, we use this function create from config, and the funny thing is that if now we send a message to it, like in the testnet, it wouldn't work because we initiated this contract. So let me get back to it a bit. So how do we deploy the contract to the testnet? It's important to know that contract is like code of the contract and the data in the storage. So once we look at the contract and we initially put it into the blockchain, it has a code and it has a data. So the code is run against the data, initial data, and create from Fig, which is a wrapper actually. So these wrappers, they're pre-generated for us. You don't have to Yeah, now it's working. And I also need to, yeah, and my screen is also working. Okay, can you please keep an eye on that? Just checking. You can just open this page and you just see everything. Perfect. So I will go back to code. So basically here I have an integer like value, and I will have to say, let's see in the code what it has to be. It has to be 64-bit integer. So basically I'm also passing the size, so 64. So in this way, I'm composing a new cell with the initial data. And this cell is going to be put into the memory, and it's going to be read from this initially. So, okay, I save it. So basically, we understand what happens. We have create from config. The config is value, it's code, work chains. We don't need to talk about this now. So here I do data. Actually, I can even just go with this. Let me make it very, very, very kind of. I'll keep it here, but we should very much understand what's going on. We build a cell with data, and then we for the contract we have to do this init object. It has code and it has data. So we pass the work chain number. We don't need to talk about this now. And important thing, contract address. So let me console here. Console log contract address from work chain, and oh, okay. 42. 42 is fine. This is the downside of doing tutorials on wrappers, because like so many code that we didn't write and it appears in front of you. But let's stay tuned. Ask me questions, okay? If you don't understand something, you get lost something, please ask me questions. So here we console log the address of contract, but it never touched the blockchain even. How do we know it? So basically in Tron, the addresses are actually predetermined. So we could say what is going to be the address of the contract before we even deploy it. And the address of the contract is basically it consists of the initial data and the code of smart contract. If you change the initial data that you put into the storage on the first run, it changes. The address is going to change. And the actual deploy to the blockchain will be like, we are sending the message with this code and initial data. We are sending a normal message to the address that we calculated. So we compose a transaction of sending some data to this address. We give it to validator. It will see that this contract is not even deployed yet. So it will run it first time. And since that moment, it will be deployed on the blockchain with the address that we could calculate before. So this is why we are going to know, like here. So for example, you have to play a lot with this library sandbox, because it gives you so much like local development tools that you can work with. And so this contract class that we actually extended with, and we called it Pascal case, but this contract class, you see, it has to get an address. So that's why we actually calculate the address. We calculate the address, and also, what else it needs? It needs this object like with code and data, two cells as an object. So this is why, here, yeah. So create from config, we actually return a new contract, which we call it Pascal case. And basically, this is going to return us a contract and we are going to play around with it. So does it make sense for everyone how we actually compiled the contract, and now we're able to interact with it? Who's not sure that he understands? So I'm just supposing then that we're fine. Everyone understands what's going on, right? Okay, so now this is just a simple test that is going to like test if it can be deployed. But now let's I think also we would have to recreate the contract before each. Yeah. But like this. And let's like we got a contract that we didn't know, and that's why we would have to be creative. Let's write yeah, Pascal case contract. No sound up opened contract. Open contract. Okay. It will be of this type. Yeah. So now, before each test, we are going to have a clean version of the contract, and it really you have a lot of flexibility on that. But I will just try to play around the way I can. So what we are going to try to do is we are going to try to get test number. But actually, let's not even play with test number. Let's just immediately get number, because I think it's going to work, because we initiated it with the number 42, and we will expect the get number to return 42. And should get value. Okay, const value, await, case. Wait, this is open contract. How do we call getter methods? Wait. Contract provider. Wait. Get NFT. We would have to do a wrapper. Sorry, guys. I have to think of it on the go. So we have a contract open. We will extend the Pascal case contract with get data, and it's going to return, basically, it's going to return Pascal config as well. And here we run the get number. So this is contract provider. It is running get method on the, we specify which number, which of the getter methods we want to use. And I believe, let's see what we have in the stack. I will just return 0 for now. Let's see what we have in the stack. And here we write blockchain open contract, Pascal case. Do we actually have to open contract? I'm not sure. Vlad, you follow through? Yeah, let's just play around with it. I will do it like this now. Just I will do like contract. I will create from config. Now this contract, I will run get data, and let's see contract provider. It needs contract. Oof. It's been a while since I wrote some of this. Mm-hmm.
What's the case of that contract?
Sorry?
What's the case of that contract?
No. I need to pass. So the get data is waiting for provider. And
What's the case?
I'm not sure. But no. How do I get provider? I'm just forgot about it. Sorry? This one?
It's like whatever it is. It's like Tom 13 version.
Yeah, it's all the latest libs. So some of them, it was changing so fast in Ton, but it's very intuitive. It's supposed to be very intuitive. We will figure it out now. Let me try something. Wait, I will go back. I will npm create Ton, and this is what I could actually. Will be useful for you as well. That you should always look at someone else's code to understand how things work, because Ton is very young, and for many things there is not even proper documentation, and things are changing fast. So you should get the latest code possible. So sample contract. I will generate a sample contract, a simple like the counter that provides with this npm create Ton, and I'm just going to have a look how they treat this provider of contract.
So this real development in the Atomic system, there's nothing like prepared and nothing.
Yeah, but it's fine.
That's how it looks like. It's not Hollywood movie where you make like the system in seconds.
Yeah, we're going to make it. We're going to write the test now. We're going to figure out. No worries. Okay, I have. Okay, I would have to sample contract. I would install everything, but first of all, I need to go to tests. Okay, so they create a blockchain, and okay, they do counter, they open it, expect, send, deploy, get sender. How do they get run? Get counter, opened contract. What is get counter? Okay. What does it provide? Nothing. Get counter. The hell. Wait a second. It is actually calling the. Okay, it's calling the get counter. But it doesn't provide it with the provider. Very nice. Get ID method. Okay. Counter. Promise. Provider. It wants a provider. Can you help it?
So they have increased that get sender, as I can see in the library, and So you can see a send increase,
Mhm.
where they call send increase. They have the increase build send. Yeah, and this is like treasury is like provider. I don't know why, but
Treasury is like provider.
yeah, I mean that they use this variable as provider, and they waiting this variable as provider in send increase function.
Increaser, treasury. Okay, get counter. Increaser plus E.
Like
Okay,
in,
let me try.
in other projects, we get used to Tom version 12 and like other
Mhm.
libraries, and they're like so simple in those libraries. So in other projects, we have just create from feed, and then we will get method, and that's it. In this library, we have
Open contract, treasury contract. Treasury provider get. Yeah, this is the very new latest thing, and I'm now figuring it out on the go. But this is good. Good. When you call NFT team get data, you need to supply the provider argument. It's done for you on opened instances. The provider will query the smart contract contained in blockchain and parse the data according to the code. Note that unlike the send methods, get methods on open instances will return the original result as is to the core. Note that all of the methods for contract that you want to open that start with get send need to accept provider as a first argument, even if not used, due to how the wrapper works. Okay. We would need to have an open contract for this then. So we have an open contract, Pascal case. Yeah. I think I understood what's wrong. We have this Pascal case is an open contract, and an open contract, the provider is passed automatically. So now it's going to work. Oh, wait. I'm in the wrong repository here. Let's go into Tone Workshop. Do yarn fast. So we were trying to do what? Run this get data. Trying to run a get method on non-active contract. Interesting. So basically, let's try to create this contract in here by ourselves. Open contract. Huh? Sorry? Oh yeah, I understood. That's a good point though. Let me just copy stuff like this. Yeah, we had it already. I would expect to have a transaction. Send deploy. Yeah, we have deploy transaction. And now, you mean like this, right? Yeah, I just want to see. Yeah, thanks. So basically, we would expect data value to equal 42, because we initiated it with 42, right? All right. I kind of like it. This is much more advanced too, like so much flexibility if it's actually like deploy. And I love this, have a transaction, received 0, expected 42. Nice.
You can go to the function like below to the get data function and say,
Oh, yeah. But we see the stack. Oh, yeah. I forgot already what I did. Okay. So we have to put here like stack. You see, stack has the tuple reader. Okay.
items.
Do we have the item there?
Yeah, the items.
No.
Just to read,
Read number? Really?
it's probably would be a big number.
No, I think it's going to work now. Okay. I should program more. I do tutorials and everything, but I don't program a lot. I should do. Yeah, it works. So we initiated. Okay. Whew. Cool. If anybody was scared that we're not going to make it, we made it. Who understands what's going on? Nice. So let's just review one more time what happens here in the test file. Let's close the stuff we don't need. And is the broadcast doing well?
Yeah, I just watched that.
I hope this is going to be the part that didn't work. No one will see how we were struggling with this library. But anyways, wait. I want to remove this console. We don't need it anymore. And basically, let's review. Should get default initial value from the storage. Okay, so we create a contract from the config. As you remember, we pass some data, we pass the code, and we get an instance of open contract. Now we create a certain treasury. Maybe here's a good explanation of what is treasury. Okay, so good example of this is the treasury. Okay, I will send this, and you guys can read the documentation here. And basically, treasury contract here, as far as I understand, I'm not sure what's happening here in this line. Do you have an idea, Nikita? What is treasury? Okay, this is a very new thing. So the guys released it maybe 2 weeks ago. 2 weeks ago, they released the latest updates, and we are still in the process of discovering it, but it's working quite fine. So basically, we deploy the contract on the local emulated blockchain, and we actually expect the transactions, like deploy result. You actually send deploy. We expect to deployer is a wallet. So we actually create an instance of a wallet, and this is like a seed phrase. Yeah, you see, treasury is seed. So what it means is like we take a seed as an input, and we generate an address. If you change the seed, it will generate a different address. If you put the same seed, it will again generate you like the very same address like before. So basically, deployer, let's even call it like deployer wallet. So deployer wallet. So basically, after sending the deploy transaction, we expect the set of transactions that result to have a transaction from deployer address to our contract address. And this should be a deploy. transaction, because as I said, the deploy transactions, they have a code and initial data with them, right? So basically that's what happens. And then we do, as you remember Pascal case, this is our contract, right? So we run a get data method, and here you can actually see that we get a stack. So this provider, we run a get number get method, and we return just from this stack, the first thing that is going to be there, it's going to be number. So we read integer. Nice. So now we can continue. So let's look at the code again. So we actually got the getter properly. This test number, I don't even think we need it anymore. But what we need to do is we need to send we need to compose a message. We need to compose a message that is going to be sent into our contract, and it is going to have like operation code in it, query ID, some value that we want to add. So we would actually read the data before, then we would send this message, and then we would read data after. So we continue, or you want a break before this? Who's tired? No one's tired? Yeah, let's continue then. So you see, in these wrappers, we have a good structure that we will just write a send increase comment. So we will write a function that is going to be that is going to be called later on. So we create a function send increase. We have this provider. So via is going to be like who is sending it. So it's going to be our treasury. Yeah, from here. And the value, we can actually do number here. So great. What are we doing here then? We yeah, we're going to use this body. So basically, provider is going to be an actual like instance of contract. So we do provider, we send internal message because our contract is handling internal messages. And we're actually going to send internal message from the treasury, from this treasury wallet, the address who interacts with. And here we are going to pass value is not a some type string or big int. This has to be a big int. Sorry, I didn't hear.
It's a founding command.
Okay, yeah, that's why it's supposed to be a big int. And here it's interesting. So here is the body. Let me yeah, it's message body, and I will call it in message body. In message body. So we actually now compose this message that is then going to be parsed by the contract. So we do begin cell, and then we have to do store uint. This is going to be OPEC code. What kind of OPEC code do we expect? One or whatever. One or whatever, yeah. So it's going to be 32 bits. So in message body, send increase. Let's call it message value, because not to mix it up with, because also we are going to increase value. We're going to have increase value. This is going to be a number. So we're going to store uint, increase value. How much was it? 32, right? Oh, first we put OPEC code, sorry. So this is not increased value, we put 1, 32. Then we put query ID. I'll just put 0 because at the moment we don't need to work with it. We don't have chains of transactions, so we don't need it. But we just showed it for you. So once you see QID, you understand this is like just a best practice, like the agreement that we have among developers. And what's next? So we have opaque code that is going to be 1. And now we have to put the 64-bit integer store uint, and we are going to put increase value 64, and we have to end cell. So this is the message body that we are going to send into the contract. And let's see how it's going to work. So first of all, it's like, so it doesn't fail. Let's just continue in the same test, so we wouldn't have to recreate the thing. So we are going to do increase result, and it is going to be equal to await Pascal case. It's going to be send increase. So it's going to be deployer wallet address. I think that's good. I hope. Then we provide message value and increase amount. Yeah, it's not gonna work. Now it's gonna work. And let's see what is the increase result actions. We run again yarn test. Is it not too dark? You guys can see good? Because it's like it's blurry here, no? So it worked, and we got transactions here. So I'm curious. So generic transaction. We can see this like 0.05 tone. I'm just curious. We need to check the status. We need to check the status of the transaction if the execution actually was successful. Let's again get back to the sample contract that we saw here. So increase by, so result to have transaction success true. Okay. Get counter. Yeah, okay. Basically, this to have transaction thing, it is very handful because we would then expect increase result transactions, whatever you saw already now in the bottom. We would expect to have transaction, and this transaction would have to be from to, okay, from is going to be deploy wallet address. Have a transaction. From to Pascal case address. Value has to be this, and success should be true. So this should be successful. So when transaction is coming in, basically this transaction can fail. If our contracts fails, this transaction will actually fail. So I would expect it to be success. Let's test. Okay, it's passed. But what is important that we have this, it's 42. We send 1. So now we need to run the get data again. So after the transaction succeeded, we will go with like new data. It's going to run the get data again, and we would expect new data value to equal 43, right? Because like, yeah, it will initiate with 42. We send the increased transaction by 1, and then we actually do 43. Yeah. So basically, this is the good test that our contract actually works on chain. So maybe we can, because I see that we're less and less with every moment, let's deploy this contract. Let's, yeah, maybe even like, do we want to deploy it now or do we want to do it tomorrow? Like, because we would,
Here,
huh?
finish here and like finish it now and finish the contract tomorrow because it's already 2 hours 40 minutes.
Yeah. We already, we went through a good solid amount of learning. You guys are heroes. Who's left, you guys actually tell. Let's do like kind of like a Q&A. What do you think? What, like, you went through this workshop. It's your first encountering Ton. What do you think? Did you learn something new? Does it make sense for you? What would be your opinion? Anybody can say. Shock. Shock. So is it like pure shock? Do you understand how to write a contract now? So let's say if I ask you to write a contract that would be able to handle 5 different operation codes, it would not just multiply divisions. So you would have to yeah, let's do multiply and manipulate. So 5 different operation codes and manipulate the storage. Would you be able to do that? No?
Yes, probably.
Huh?
Yes, probably.
Probably. Who can do that? Who thinks he can do that?
Maybe you should make.
Nikita, are you sure? Nikita, are you sure?
I have one problem.
Yeah.
I have error in include line. I can include inputs from STT lib.fun.
Okay, I can check it after.
Yeah.
Session. I can help.
But all in all, we think we are good, right? We kind of went through a lot of.
Yeah, guys, if you want to, maybe you'll be interested to make some home tasks before tomorrow. So and tomorrow on the before like second workshop, you'll be able to check like how it's going on. And if you have some questions with then we can help you and refactor it and like do what
Yeah.
we can.
But I have to tell you, I'm really happy that you guys stayed so late, like until so far. And
Yeah, it's almost 3 hours of like pure coding, like pure FunC and script library understanding.
can I ask you one thing that you promised me? If ever you will have a feeling like this is too much, not now, but you're going to hackathon passes. After 1 month, you try sometimes, and at some point you're like, I will never make it. Tone is too complicated, whatever. Can you promise me you will text me and I promise you we sit 1 hour and we talk. Maybe I will try to help you because I just really don't want people to leave because it's too hard or something. Because in Tone is like you have to spend some time around and you will start understanding things because there's some things that are just not documented. And you will just at some talk all of a sudden someone will say one phrase and it will make sense for you. So basically I'm trying to repeat same things again and again and again. Like no, it took me 1.5 weeks. So someone would tell me that the addresses can be calculated. Everyone's like, calculate the address, calculate it. I was like, the hell? What do you mean calculate the address? And then you just need to understand and go through a few concepts, right? So don't leave Ton if you like it's complicated. like I can be your like 911.
Actually, I think the good thing about high level of complexity and high level of entry point is that you will be really needed in terms of working. You will be really high pay developer. High pay developer.
Yeah, I mean, I am not high paid developer. How can I be? should I go to Tanana?
So
Yeah.
because there are not so much fancy developers, and like a few hundreds of them, and they're a huge market growing right now. And so in a few years, I think it will be a big market, and it will be really possible to receive like big salary
Hopefully, yeah.
for fancy knowledge.
Yeah. But if you learn and at some point you say, I'm ready for some practice, also text me. I will try to talk. I talk with a lot of teams. Maybe some team will actually, like young team, will actually able to take you, and so you would practice your FunC skills. And also there is a lot of nice groups, so don't leave. Like there is a lot of nice stuff happening in town. So for example, there is a group FunC gang. Like there's dev chats, but there's FunC gang. And there's like in dev chat there's like a few thousand, I think at least 2,000 people. They never even touched FunC. They just, oh, maybe one day I will learn FunC. They go in there and they do spam sometimes. I don't go to dev chats, for example, but there's group FunC gang where I know like pretty much every developer who's there, and they're able to answer so many questions. So it's just,
Yeah, just drop the video of how you see here coding, and like it's really nice that people being here.
did you send it in the FunC gang?
Yeah,
So what do they say?
I mean that they're happy that we doing such stuff. In that sense. So I think we can finish here and stop the stream, and
Yeah.
tomorrow we will have another talk. So that's it.
Yeah, guys, thank you.
Thank you.
Thank you, Vlad. You're a good teammate for such a hackathon. Okay, so можно останавливать.
So guys, thank you very much. Let's do a small break and continue with the lecture about lending DeFi.
Слушай, наверное, мне кажется, очень подустали. Make sense, типа,
В смысле, вообще на сегодня вообще
просто не знаю, типа, вечер уже. Продолжить можно или можно завтра поставить?
Ладно, давайте посмотрим, как.
Сейчас. Пойдем сядем.